Lesson 10.3, Graphing Cube Root Functions. Essential question: how can you use transformations of the parent cube root function to graph functions of the form f of x equals a times the cube root of x minus h plus k, or g of x equals the cube root of 1 over b times x minus h plus k? Are we seeing some of the same? We're seeing some of the same. You got A, you got H, you got K, you got B. These all do the same thing with cube root functions that they did with square root functions, that they did with parabolas and such. So it's still the same thing. It's still the same thing. Graphing and analyzing the parent cube root function. The cube root function is f of x equals the cube root of x. To graph f of x, choose the value of x and find the corresponding values of y. Choose both negative and positive values of x. Graph the function f of x equals the cube root of x. Identify the domain and range of the function. So let's do that. We're going to make a table of values. So we've got negative 8 here. So f of negative 8 equals the cube root of negative 8, which is negative 2. So that gives us negative 2 here, and it gives us an order pair of negative 8, negative 2. And we'll try negative 1. F of negative 1 equals the cube root of negative 1, which is negative 1. And so that gives us negative 1, negative 1. And then f of 0, well, cube root of 0 is 0. So that gives us 0, 0. And f of 1, the cube root of 1 is 1. So we got 1, and then that's 1 and 1. And then f of 8 equals the cube root of 8, which is 2. So that's 8, 2. Use the table to graph the function. So let's graph it. We've got negative 8, negative 2 is right there. And then negative 1 is going to be right there. 0, 0, 1, 1, and 8, 2. So let's see here. Let's see. That's going to go like that, and that's going to go like that. And there we go. Identify the domain and range of the function. Well, the range is, or the domain is the x values, and it covers all the x values. So the domain is going to be all real numbers. That's terrible looking right there. The range is the y values, and you see it's got a slide up and it's got a slide down. So again, eventually it will cover all the y values. So it's going to be all real numbers. Does the graph of f of x equals the cube root of x have any symmetry? Well, look, it does, because you got 1, 1, and you got negative 1, negative 1. You got 8, 2, and you got negative 8, negative 2. So it has what we call point symmetry. Point symmetry. Good deal. And can the radicand in the cube root function be negative? Yes. Yes. And that's because the cube of a negative cube of a negative number is negative. The cube of a negative number is negative. Graphing cube root functions. Here we go. K moves it up and down. H moves it right and left. A, vertical stretch or vertical compression. B, horizontal stretch or horizontal compression. And don't forget the reflection. Negative, like a negative A will reflect it across the x-axis, and a negative B will reflect it across the y-axis. Now this right here is this right here and that right there. Okay, that'll help you immensely do the transformations. For the function f of x equals a times the cube root of x minus h plus k, hk is the graph's point of symmetry. Use the values of a, h, and k to draw each graph. Note that the point 1, 1 on the graph of the parent function becomes the point 1 plus h, a plus k on the graph of the given function. For the function f of x equals the cube root of 1 over b times x minus h plus k, hk becomes the graph's point of symmetry. Note that the point 1, 1 on the graph becomes the parent function, becomes the point b plus h, 1 plus k on the graph of the given function. So go ahead and follow A, and when you get back, we'll do B together. Graph g of x equals the cube root of 1 over 2 times x minus 10 plus 4. The transformation of g of x equals the transformation of g of x equals the transformation of the graph of f of x. Graph g of x equals the cube root of the cube root of 1/2 times x minus 10 plus 4. Okay, the transformations of the graph of f of x equals the cube root of x that produce the graph of g of x are a horizontal stretch by a factor of 2. A transformation of 10 units right and 4 units up. Choose points on f of x equals the cube root of x and find the transformed corresponding points on g of x equals the cube root of x, the cube root of 1/2 times x minus 10 plus 4. Graph g of x equals the cube root of 1/2 times x minus 10 plus 4 using the transform points. All right, we'll do that. We'll do that. So let's take a look at it. H is 10. K is 4. And we have B equals 2. So how are we going to do that? We're going to go 2 times x plus 10, and then we're going to have y plus 4. Okay, so 2 times negative 8 is negative 16 plus 10 gives you negative 6. Negative 2 plus 4 gives you positive 2. And then 2 times -1 is -2, plus 10 gives you +8, and -1 plus 4 gives you 3. And then 0, 0, that's really just your h and your k. So that's going to be 10, 4, and 1. 2 times 1 is 2, plus 10 gives you 12. And then 1 plus 4 gives you 5. And 8, 2 times 8 is 16, plus 10, that gives you 26. And then 2 plus 4 gives you 6. All right, let's graph those points. Let's see, that's -4, -6, 2. It's going to be right there. 8, 8, 2, 3 is going to be right here. And let's see, 10, 10, 4 is going to be right there. And then 12, 5 is going to be right here. And then 24 is going by 4. So that's 28, that's 26. 26, 6 is going to be right there. It's going to look like this. And then that's going to go down here like this. All right, not too shabby, not too shabby. And let's try your turn. Let's try your turn. Graph the cube root function. So let's graph this. Let's graph this. What is h? What is h? H is 3. What is k? K is 6. Is there an a? Well, I guess you could. You could say a is 1 and whatnot. All right, so how's this going to work? Well, we're going to take x and we're going to add it to 3. And we're going to take y and we're going to add it to 6. And that's going to give us so -8 plus 3, that's going to give you -5. And then -2 plus 6 is going to give you 4. -1 plus 3 will give you 2. -1 plus 6 will give you 5. And let's see, 3, 6, that's our h and our k. 1 plus 3 is 4. And 1 plus 6 is 7. And 8 plus 3 is 11. And 2 plus 6 is 8. So let's -5, 4 would be right there. And 2, 5 would be right here. 3, 6 would be right there. And 4, 7 would be right there. And 8, 10, 11, 8 would be right there. So let's draw that. And it looks something like that right there. Not too bad, not too bad. Writing cube root functions. Given the graph of the transform function g of x equals a times the cube root of 1 over b minus or x minus h plus k, you can determine the values of the parameters by using reference points -1, -1, 1. It should be -1, -1, 0, 0, and 1, 1 that you use to graph g of x in the previous example. So, folks, there's a little typo there. There's a little typo there in our book. That should be -1, -1. Okay. All right. For the given graphs, write a cube root function. And we'll let you go ahead and go through all of that. And when you get back, we'll go to B. We'll go to B. Write the function in the form g of x equals the cube root of 1 over b times x minus h plus k. Identify the values of b, h, and k. So let's see here. Identify the values of h and k from the point of symmetry. So let's look at it. Where's the point of symmetry at? Where is the point of symmetry at? And I'm seeing it right here. That's the point of symmetry. Okay, so h would be 2 and k would be 1. All right. Identify the value of b from either of the other two reference points. The rightmost reference points has the general coordinates b plus h, 1 plus k. And so we're wanting to this one right here. Okay, so what is that point? That's 4, that's 5, 2, right? So that's 5, 2. So remember, that's going to be 5, and that's going to be 2. The rightmost reference point has substituting 2 for h, and I'm getting that 2 from right here. Okay, this right here, that's 2, 1, right? Okay, so 2 for h, so and 1 for k, and setting the general conditions equal to the given coordinates, to the actual coordinates, gives this result. So b plus h, and what does b equal? What does b equal? Well, I kind of like to go off over here to the side. Let's see here. B plus h equals 5. And I'm going to say 1 plus k equals 2. 2. Now, what do we know? We know that h is 2, so we're going to put a 2 in there. We're going to put a 2 in there. All right. And we know that k is 1, so we're going to put a 1 there. All right, so 1 plus 1 is 2. That worked out real well, but we don't know what b is. If we subtract 2 from both sides, we get b equals 3. So we can put b equals 3 in there, and h equals 2, and k equals 1. So the function is g of x equals the cube root, and that's going to be 1 over 3, and that's going to be x minus 2, and then we got plus 1. And we've done it. We have done it. Your turn. For the given graphs, write a cube root function. Okay. All right. So write the function form g of x equals a times the cube root of x minus h plus k. The hardest part really is finding that point of inflection. Because you see, you got 3 here, but remember that point of inflection, that's going to be right there. So that's -2, and then 2, 4. So that's going to be -2, -5. Good. So this -2, -5, that is your HK. Now, which formula are we going to use for this? We got A. So we've got h plus 1, and we have a plus k, right? So let's split this up. H plus 1 equals -2, and a plus k equals -5. Now, what do we know? We know h is, h plus 1. We know h is -2, right? And we know, oh man, I put the wrong numbers in there. And we know k is -5, right? Now, we were supposed to pick a separate point, and let's just use, which one? 2, 4, 6, 8. We can use, well, let's use that point right there. What is that point right there? It's -1, that's -1, -3. So we'll put a -1 in here, and we'll put a -3 right here, okay? Because that's the transform point. So here we're going to add, well, -2 plus 1. Oh, that works out. That worked out real good. But we still got a variable here. So let's add 5 to both sides. Add 5. So we get a equals 2. That worked out real well. Okay, so g of x equals, that's going to be 2 times the cube root, and that's going to be x minus, well, what was h? Was -2, so that's going to make that x plus 2, and then minus 5. Not too shabby. Let's try number 4. Write the function in the form g of x. Okay, so we're going to need to figure out what b is. We're going to need to figure out what h is, and we're going to need to figure out what k is. And we can find the h and k relatively easy. We just got to find the point of inflection, and that's right there. So that's going to be -3 and 2. So -3, 2. All right. So we've got -3 here and 2. All right. Now we're going to use, we got b plus h, and we have k plus 1. All right. Well, we need to find a point of inflection. We can use this one, or we can use this one here. That one's not too bad. So what is that? That's going to be -5, and it looks like 1. So we're going to have b plus h equals -5, and we're going to have k plus 1 equals, and it's 1. All right, so what do we know up here? We know h is -3, so we'll put that in there. And we know k is 2. And since this one's here, I should be using, well, that's -5, and that was supposed to be -1. That should have been -1. Okay, that's -1. All right, so this is -5. All right. So if we add 3 to both sides, we get b equals -2. That's b. That we should add 3 to both sides, and that still gives us -2. Should I have chosen the other point? No, I'm trying to do what am I doing? I'm doing the negative 1, negative 1. And I should be doing not the negative 1, negative 1, but the 1, 1. Okay, so I need to be using this point right here. I need to be using that point right there. And that's going to be negative 1, and that's 2, that's 3. Negative 1, and that is 3. Oh, we'll see how that worked out. Okay, and then if we add 3 to both sides, we get b equals 2. So g of x equals the cube root of 1 over 2, and that's x minus, what is a? Oh, that's plus 3, and then plus 2. So see how you can check which point you're using? You can check it. If it doesn't work, then you're probably using the wrong point. What do we got here? Modeling with cube root functions. You can use cube root functions to model real-world situations. So I'll let you do A, and when you come back, we'll do B together. All right. B, the velocity of a 1,400 kilogram car at the end of a 400-meter run is modeled by the function V equals 15.2 times the cube root of P, where V is the velocity in kilometers per hour and P is the power of its engine in horsepower. Graph the function and examine its average rate of change over equal P intervals. 0 to 60, 60 to 120, 120 to 180. What is happening to the average rate of change as the p-values of the interval increase? Use the function to find the velocity when p is 100 horsepower. All right. The graph is a graph of f of x equals the cube root of x stretched vertically by a factor of 15.2. Graph the transform point 0, 0, and then 8. And what I did was I just put 8 in there, and I got 30.4. So I put it in my calculator. 15.2 times the cube root of 8 is 15.2 times 2, which is 30.4. Okay. And then 27, that would give you 45.6. 45.6. 64 would give you 60.8. 125 would give you 76, and 216 would give you 91.2. Connect the points with a smooth curve. So we got 0, 0 here, 0, 0 right there, and then we got 8, 30.4. And what was that? It's like right there. And then we got 27, 45, says 20, 40. So we're doing 20, 27. That's going to be like right in there, maybe 45. And then 64, 64, 60.8 right there. And then 125, so that's 120, 125, and 76. That's going to be a little closer to that there. And then, let's see, 140, 160, 180, 200, 220. So it's going to be close to the inch. And that's 91.2, maybe right in there, something like that. All right, so let's see if we can't Connect these smoothly. All right, so it would look something about like that. The average rate of change over the interval 0 to 60 is 60. Well, that would be 60, 0 to 60. That's going to give you 59.5 minus 0, and that gives you 0.99. The average rate of change over the interval 60 to 120 would be 75 minus 59.5 over 120 minus 60, which is about 0.26. The average rate of change over the interval 120 to 180, that's going to be like 85.8 minus 75, which is about 0.18. I did all that in the calculator. The average rate of change is becoming less. It's flattening out. It's becoming less. Substitute P equals 100 into the function. So 15.2, and we'll put 100 in there. So 15.2, and that's like cube root of 100, that's like 4.64. So that's 70.5. 70.5. The velocity is about 70.5 kilometers an hour. Our turn. The fetch is the length of water over which the wind is blowing in a certain direction. The S of F, the speed of the fletch, equals 7.1 times the cube root of F, which relates the speed of the wind S in kilometers per hour to the fetch F in kilometers. Graph the function and examine its average rate of change over the intervals 20, 80, 80, 140, 140, 200. So what I did was I just use these numbers here. I put those numbers in my calculator so that I could do that. And for 20, I got 19.27. And then for 80, I got 30.59. 30.59. That's 80. 80. And then for 140, I got 36.87. And for 200, I got 41.52. Okay, so let's graph those. You got 0, 0. At 20, you got 19.27. 20, you got 19. That's going to be pretty close to that. At 80, 60, 80, you got 30.59. So that's going to be just a little over there. At 140, you got 36 point. Yeah, that's going to be close to 40. And then at 200, so 140. At 200, you got 41. That's just a little over 40 right there. And let's see if we can't connect them with a nice smooth curve. All right, so there's what that looks like. Now, it wanted to know the average rate of change over these intervals. So we're going to have 80 minus 20 in the denominator, and that's going to put 30.59 minus 19.27, and that gives me 0.19. So that's that average rate of change. And then the next one was 140 minus 80, 140 minus 80, and that's going to be 36.87 minus 30.59 in the numerator for an average rate of change of 0.10. And then the last one was 200 minus 140. So that's going to be 41.52 minus 36.87. And that's going to give you 0.08 as that's average. So the average rate of change is becoming less. The average rate of change is becoming less. It's flattening out. Probably never actually get completely flat, but it's headed in that direction. Why is the domain of f of x equals the cube root of x all real numbers? And the reason for that, well, the reason why it couldn't on the square root is because square root functions were not defined for negative numbers, but they are for cube roots. And because you can take the cube root of a negative, because you can take the cube root of a negative. You can also take a cube root of 0, and you can take a cube root of positive numbers. That's why the domain of f of x equals the cube root of x is all real numbers. Number 7, identify which transformations, stretches or compressions, reflections and translations of f of x equals the cube root of x change the following attributes of the function. Okay. That's kind of a tough question there. So, location of the point of symmetry. Which of the following transformations? The only thing, well, there's two things that change the location of the point of symmetry, and that would be H and K. H and K. Well, let's see. If H is not equal to 0 and K is not equal to 0, the horizontal and or vertical translations change the location of the point of symmetry. So H can change it, K can change it, and H and K together can change it. Symmetry about a point. No transformations can change the symmetry B. No transformations can change the symmetry about a point. Essential Question checking. How do the parameters a, b, h, and k affect the graphs of f of x equals and g of x equals? All right, so what goes on there? What does a do? What does a do? A gives a vertical stretch or compression. And what does B do? B gives a horizontal stretch or compression. H gives a horizontal translation left or right, and K gives a vertical translation up or down. All right. Good job, folks. Well, I'll see you tomorrow in class. Y'all have a great evening.